Hello and welcome to the Tin Barn. I'm Pragmatic Lee, and I'd venture to say that based on the intro to this video, you probably already know what I decided to do with the air motor that I asked for input on a couple of videos back. The number one suggested item for the air ram was a can crusher. Already got one of those. As far as the motor itself went, tool post grinder was the overwhelming suggestion for it, but I already got one of those too. Someone else suggested a rotary attachment for the surface grinder. I got one of them. Guy over at MKE Gadgets, I'm sorry I don't know his name, I think it's Mike, but I'll put a link to his channel down in the comments, but he suggested a paint can shaker. I hadn't even thought about that, and that's exactly what I decided to do. Let me zoom you in a little bit closer on the shaker. This is going to be what I like to call a reverse build. The item is already built, it's tested, it works. What I'm going to do now is point out each item on the shaker and show you how that item was built. Basically, recorded all those pieces ahead of time, and now we're going to do a reverse build. Yep, I still got all these Brown and Sharp boxes over here. I'll get to those maybe within the next couple of weeks. Okay, the air motor mount itself was in my last video, but it is mounted on this base. The air motor, the muffler, the inlet air comes in here. This is a regulator, pressure gauge. This is an oiler. This motor needs a pretty regular, constant supply of lubricating oil. So this is an oiler in line, and it's plumbed over to the input side of the motor. All right, in this reverse build, the first thing we're going to look at is this drive wheel down here. I call it a drive wheel. The next thing will be, see if I can get it, the Pitman rod and the shoulder bolts. Then we'll look at the driven wheel up here. Then this vertical mount and the axle that goes through it, bearing and axle that goes through it. This shaker wheel is basically the same thing as the driven wheel, but the holes obviously are a little different. The shaker arm, this piece, the shaker cup, then the shaker ring. The drive wheel that's going to actually mount to the motor will be 1.5 inches in diameter, 1/4 inch wide on the flange, 1/2 inch wide on the boss. There'll be a 3/8 inch hole through the center for the motor shaft. This will have a set screw right here. This boss is 0.725, 1/2 inch wide, and again 1/4 inch here. All right, I got a piece of 1.5 inch stock in the lathe now. What I'm going to do is come in, just touch that off right there, zero out the Z-axis, come into 1/2 inch, and set the carriage stop on the lathe. All right, let's start turning some material down. We want to turn this down to 0.725. All right, now I'm going to take a measurement there, set a value into the DRO, zero out the x-axis. We currently have 1.423, and we're looking for .725. So we got about 698 thousandths to go. DRO says we should have about 20 thousandths left to go. That's 740 and we're looking 725. So that's 15 thousandths. And we'll clean that shoulder up on the way out. But now we want to get it set up to part this off. Line that up with the edge, zero out the z-axis, and come in 0.275. Sorry, 0.250, quarter inch. And of course it had to fall down in the drink. I'll fish that out. Got the piece fished out of the drink now. We're going to turn it around, snug it down, and face off this edge here. Get rid of that little tip that was left over, and be sure we got a good flat surface, because again, this is the drive wheel, so we want this surface here to be as smooth as possible. Now we're going to center drill it. We're going to drill this with a 64th less than 3/8. So that would be a 23/64. Motor shaft is a 3/8. All right, now we're going to ream this out with using a chucking reamer, and this one is 1/1000th over 3/8. So that should give us 1/1000th clearance for our motor shaft. And I had several comments before in a previous video talking about reaming, and got some good feedback on that. When folks said I was really needed to slow down my RPMs, no matter if I was reaming on the mill or the lathe. So I've got that slowed down pretty good now. Get in, do your business, and get out. All right, let's look at the motor now. Again, I don't use the term perfect very often, but that's as perfect as I can do it. So let's turn over to the mill now. Okay, I've got the drive wheel mounted in the mill vise now, and I've already found the center on the x-axis and moved back 1/4 inch on the y-axis. So we're going to drill and tap this for 1024. There's probably going to be a whole lot of 1024 drilling and tapping in this project. Starting out with a 2-fluted spiral tap. And we'll finish the hole out with a 4-flute bottom tap. All right, let me get set up for the final operation on the drive wheel. Okay, you remember we drilled this out, or we reamed this out to a thousandths above 3/8, so 376 thousandths. So I've got a 376 pin now. Let me loosen my axis, and we're going to use the pin to center up with. Let me tighten that just a little bit to be sure it's not sliding up in the chuck. No, it's not. Okay. So there is our center. All right, we're going to move to the outer edge now. We're going to drill and tap another 1024 on the outer rim of this. Zero out the x-axis. Remember, our probe on here is 200 thousandths, so we'll move over half of that, which will be 100 thousandths. Now we want to come in 1/8 of an inch, 125 thousandths. And that will be the hole for our offset on the drive arm. All right, so there's our completed drive wheel. All right, the Pitman rod is nothing more than a 6-inch long piece of 1 inch by 1/4 inch flat bar. I've marked for 2 hole locations, which are 5 inches apart. I'm drilling this with a 29/64 bit, and then I'll ream it to 5/16 plus 1/1000. All right, now we'll turn over to the lathe and machine some matching shoulder bolts. All right, for the shoulder bolts, I'm going to use a piece of 1/2 inch brass. I'll zero out the Z-axis right there. And I want 300 thousandths of thread, which is a little extra, and 300 thousandths of shoulder. So that'll be a total of 600 thousandths. I'll set the carriage stop as usual. All right, I'm going to take a couple of measurements now. Okay, I've got about 120 more thousandths to go. I'm going to get that close, and then we're going to machine it to fit the Pitman rod. We'll want a loose fit, not real loose, not sloppy loose, but just loose enough where it can turn without binding. This shouldn't quite go yet, which it don't. We'll take about 5 thousandths at a time. This should be a snug fit. This is what the measurements said. All right, just a little file cleanup, and I think that should be fine. Alright, now we want to thread the first 1/4 inch of that, or first 300 thousandths. But we need to turn that down, zero out the z-axis again, which was still the same. Now I want to look and be sure that shoulder right there is beyond the thickness of the Pitman rod, and it is. So take a couple more measurements. Alright, that says we got 108 thousandths to go to get this down to thread to a 1024. Alright, now I'm going to get set up for a 1024 tap, 1024 die. And I think it'd probably be just as easy to turn over to the vise, mount this in the vise, and cut the threads by hand. Alright, I got the threads cut in there. So we'll stick it back in the vise right quick and part it off. I'll set the z-axis right there and come in 100 thousandths. That should be plenty thick enough for the head. And I know that's going to disappear down in the drink if I don't put something there to catch that. Let's see how hot that is. Alright, I'm going to turn this around and clamp it ever so slightly, just so I can knock this little tit off. Alright, I'm going to carry this over to the vise now. I don't have a slitting saw thin enough to put a reasonable slot in this, so I'll just take the hacksaw and put a screwdriver slot in the shoulder bolt. Then I'll do the same thing again, making the second one. Okay, just like I did on the drive wheel, I took the driven wheel over to the mill, drilled and tapped for the grub screw, 1024, and also drilled and tapped for the offset. In a previous video, you saw me make the mount for the air motor. The distance between the bottom of this mount and the center of the shaft is 2.5 inches. So I laid out the 2.5 inches from the bottom of what is going to be the vertical mount. I then measured 5 inches from it, which is the length of the Pitman rod, and indicated a hole here. Off camera, I just rounded this off pretty much like I did the motor mount in the previous video. Now we're going to drill this first, step drill it up to 1 inch. Then we're going to bore it out for this bearing, which is, I believe, 1 1/8 inches. Yes, 1.125. So we'll drill and then bore out for a snug fit to press this bearing in. Alright, now I'm going to get the boring head set up and bring it right back. Alright, I've got the boring head set up and I've made a pass on here. I set it to a nominal value here. Zero out the DRO. So what I'm going to do is constantly be measuring this. Try to get it as close to that clearance as possible, and like such is the case many times, this hole is almost in between this size and the next size. Alright, so like I say, I've got the DRO zeroed out. Alright, so I've got an idea of where I need to go, and I'm not going to do a lot more narration, but simply what I'm going to do is just keep boring this until I've got what I think will be a press fit. Alright, I'm not sure I could get it any better than that. I was wanting 1/1000th interference there, and according to the micrometer, that's exactly what I've got. So we're going to turn over to the press now and press this bearing in. The bearing is about 300/1000, and this is 500/1000 thick, so we'll attempt to center this. Before I go to the press, I'm actually just going to go ahead and take the axle and tap it in to the bearing to where I've got the exact same amount of space on both sides of it. Then we'll press this whole assembly into the vertical base. Okay, I've got the axle installed in the bearing now, and this is not really what you'd call a press fit, but it is enough of an interference fit so that it will turn the bearing and not turn on the race. So let's set that in. And I made sometime back I made this little mandrel for pressing in this size bearings. I've used these bearings in a lot of things. Alright, as I said, this needs to go in about 100/1000 to give the same clearance on both sides. And I think that's close enough. Good tight bearing press. Another thing I did off camera on this vertical mount was simply drill and tap 3 1024 holes. Alright, the shaker wheel was made just like the drive wheel and the driven wheel. The only difference was we did not put an offset hole in this. To hold this, I'm simply going to take a piece of what will become the axle, but it's a piece of 1/2 inch drill rod. Secure it down pretty good. And I've got one of my small V blocks setting on a parallel in the vise, and I'm going to use the small V in the V block. This just helps me to hold this piece in place. If I tried to hold it on that boss, being this soft aluminum, it would probably crush that. Plus I need it elevated that I can drill through. So what I'm going to do now is find the center. I did set a 0 on the x-axis so I can come back to that and know I'm on the same area of the circle. So there's our center. And we could do a bolt hole pattern here, but it's really not necessary. I'm only going to do four holes on the X and Y axis, so I can just use a DRO to space over and not try to do a bolt hole pattern. We're going to come 3/4 in each direction. Now I want to set the piece in on its edge and take about 200 thousandths off of each side here. And to get those lined up with the bolt holes, I'm just going to use a parallel and do that by eye, which I think will be plenty close enough. This piece is 2.4. Our arm is 2 inches. So that's 200 thousandths we need to take off of each side. Okay, I've got the piece mounted now, got an end mill in. We're going to touch off zero out the DRO. Alright, so now we can just set it right on the parallel, or set it on the edge we just milled. Touch off and set our 0. the shaker wheel we just made will mount on to the shaper arm. And since I just kind of eyeballed these flats on here, I'm not just going to try to offset 3/4 of an inch from the center in here. I actually clamp this on and use the transfer punch to transfer each of the 4 holes. So I'm going to take this to the workbench right quick, remove this, and enhance those marks just a little bit. Alright, so I've got the 4 holes here enhanced a little bit. We'll do a clearance drill for a 1024. Then we'll flip it over and do a counter bore. And before I took this piece off, I put a witness mark here and a witness mark there so I could orient the two back together when the time comes. And I hope that'll clear that parallel underneath. It should. Alright, now I'm going to find my countersink bit for a 1024 and I'll bring you right back. Witness mark to witness mark. One more thing I need to do to the shaker arm is put 2 holes in each end, clearance holes that are counterbored just like these 4 were. I'll do that off camera. Alright, I got the 4 holes, 2 in each end, drilled and countersunk, and I realized as I was starting to do this, the length that I had cut for the piece was a full length of a spray can. And I marked that with the intention of finding the center for this pivot point right here. And then I forgot to cut it off, but I went back and cut it off just to give clearance for the ring that will hold the cans. So there's the completed swing arm. Alright, to make the bottom cup, I have a piece of 1/2 inch thick material, 3.6 inches across. So I'm going to zero out the DRO right there, then bring in the carriage stop. There's our 0, and we'll come out here. We want to go in 375 thousandths, or 3/8 of an inch. That will leave 1/8 of an inch in the bottom of this piece to form the cup. Okay, now that I've got a hole opened up in there, I'm going to change boring bars and go to one a little bit larger that I don't have sticking out quite as far. Of course, I'll need to reset my carriage stop. Okay, I just took some rough measurements, and we need to take about 1.7 inches more off of the bore that much more out. Alright, that should be fine for our cup. Now what I'm going to do is clean out that bottom just a little bit. Alright, I'm going to do the same thing to another ring just like this one, except I'll be going all the way through to make the ring. This will be the cup, and I'll make the ring and bring it right back. Okay, I'm back over at the mill now, and I'm going to set both pieces in, the cup and the ring, and I want to mill a flat on this side to where it's 2 inches wide, where the swing arm, shaker arm will mate down flat with it. Probably should have got out a larger diameter end mill, but this is what I had, so I already had out, so we'll just have to take a couple extra passes. I think that's going to be close enough. It's not quite 2 inches across there. I really don't want to thin this out much more than it is. So now I'm going to take the end mill out, put the drill chuck back in, and find the center. Okay, I found the center on both the X or Y and the X axis. These pieces are 1/2 inch thick. So to get in the center, the back one will come 250 thousandths on this side of 0, and the holes in the shaker arm are 1/2 inch or 1 inch apart. So we'll move, to begin with, we'll move 1/2 inch this side of 0 and drill for our for our 1024. Now we'll move 1/4 inch on the other side of 0. Now we're 1/2 inch on this side of 0. Okay, other than a little bit of deburring, I got one more thing to do on the shaker ring. So I'll clean these pieces up a little bit and bring it right back. Alright, we're on the opposite side of the shaker top ring now. I found the center in the X and the Y axis, and we're going to drill and tie out for a 1/4 20 for the can locking screw. Alright, I think that completes the can ring and the cup. Hope you've enjoyed this reverse build of the paint shaker. Take care, and I'll see you on the next video.